of the theorems that we need to talk about when we come to relationships of segments and proving segment relationships is the Segment Congruence Theorem. Now, because the measurement of segments is real numbers, and the algebraic properties of reflexive, symmetric, and transitive deal with real numbers, we have already come up with the concepts of the reflexive property of line segments, the symmetric property of line segments, and the transitive property of line segments and their measurements. Now we want to transfer that over to the congruent statement, where we're saying that the reflexive property is true for congruence. Segment AB is congruent to itself. Symmetric property. If segment AB is congruent to segment CD, then segment CD is congruent to segment AB. And of course the transitive property, if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. Okay, as you know, and as we've stated before on multiple occasions, the measurement of a segment and the line segment itself are different. The line segment itself, as we have it here, is a picture. We say they're congruent. You can actually lay that on top of each other, and they are the same, such as pictured here. When we say the measurement of a line segment, we're talking about real numbers. Therefore, the algebraic properties come into play. We don't have to prove those. Okay? So what we're going to do next, this is the Segment Congruence Theorem. It has three sections to it. Reflexive property, symmetric property, and transitive. Now which one of those do you think would be the longest proof? That's right. Obviously the transitive property. It has more involved in it. And so what we're going to do next is we're going to prove the transitive property of congruent segments. Okay? The Segment Congruence Theorem for the transitive property. So we're going to go through that proof. And then from that, then you'll be able to look at the reflexive property and the symmetric property and be able to prove those. So we're going to be looking at the transitive property, segment congruence theorem, and proving that. So now we're going to look at proving one piece of the segment congruence theorem, and that is the part that deals with the transitive property. Now the statement of that is if segment AB is congruent to segment CD and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. Now, how do we put that into a proof? Well, proof we have to have given and we have to prove something. The given, notice this is a conditional statement. The given is going to be the hypothesis of the conditional statement. Always is. Anytime there's a given, it's a hypothesis. Anytime there's a hypothesis, it is the given. Okay, so we're going to take the hypothesis. There's two pieces to it. If segment AB is congruent to segment CD, that's one of our givens. What's the next given? If segment CD is congruent to segment EF, that's our next given. Okay, now what are we trying to prove? What's after the then? The conclusion. The conclusion is what you're trying to prove. Okay? Segment AB is congruent to segment EF. That's what we're trying to prove. Now, let's transfer that over to what we call the two-column proof or the formal proof format. Have statements over on the left side and reasons on the right side. Now, always we'll have reasons that will say given. Why? Because they've told us certain things. Why do we put given? Because they told us so. The last statement will be this statement right here, but it will not say proof on it. We will not have a reason that says proof. Do not use that. If you use proof as your reason, I will count it wrong. You don't have enough power in this class or the universe to say, QED, quite enough done, I've done my job, I've proven it. You have to give a reason. Okay? So, I always like to start out with the reasons being the givens. So I'm going to put the givens down. I like to list them one at a time. Our first given is segment AB is congruent to segment CD. Why? They told me so. Given. Second given, segment CD is congruent to segment EF. Why? It was given to me. They told me so. It was a hypothesis. Now immediately we can go to the measurement of segment AB equals the measurement of segment CD. Why? Definition of congruent. Okay? Congruent segments. Next one, CD. Measurement of segment CD is equal to the measurement of segment EF. Why? Definition of congruent segments. Have to know those definitions. You don't know those definitions, this is going to be tough. Get down the definitions. Okay, what can we say next? Well, because these are algebraic terms and deal with real numbers, it's real simple. Wow, that looks like a transitive property coming up, so we can just flat out say, wow, the measurement of segment AB, a real number, is equal to the measurement of segment EF. Why? Plain old transitive property. Transitive property. Now, in the same way that we went from congruency to equal, we can go from equal to congruency. And come back and say, oh, therefore segment AB is congruent to segment EF. Why? Definition of congruent segments. Okay? Notice our last statement is this statement. It does not have the word prove in it. It has a reason over here. Formal statement. Our givens, change them to equals. Why? Definition of congruent segments. Then we use the transitive property of algebra because why? The measurement of segments are real numbers. Okay? Then we transferred them back to congruency. Went there. Now from this point on, we can use this theorem without having to prove it. We can say that the transitive property of congruent segments works whenever we have that situation. We would not have to prove this. So anytime we have this situation, we can simply say, oh, if we have segment AB is congruent to segment CD and CD is congruent to segment EF, then we can do that. Why? Because we've proven that. Now, I suggest that what you do is using this as a sample, you then prove the reflexive and the symmetric properties of the segment congruence theorem.